All right, calculus students, this is section 3.6. This is the derivative of an inverse function, all right? And let me even tell you something that's even better. I've only got 5 slides here, 5 PowerPoint slides, and 2 of them are represented by the cover sheet right here, so there's 1, and then my assignment page on the back. So there's really only 3 that have work, okay? Now, when we think about what an inverse function is, all right, here's what I got. Imagine I have f of x is equal to, I'm just make up something easy. This is a line, 3x plus 1. And typically we know that f of x is a form of a y, okay, of our vertical axis, which we represent through a y. And remember the rule for an inverse is to take your x and your y and to reverse them. So your x is here, and your y is there. Now, some calculus teachers just prefer that you keep it that way, okay? But some of you have learned to finish this by solving for y, okay? Which means that you will subtract 1 on both sides, okay? And then dividing by what's with your y, which is, in this case, 3. And it's not that really that y is equal to x minus 1 over 3, but we represent it with a form of an inverse sign. So the inverse of x, f inverse of x is equal to x minus 1 over 3. And these are represented this way. If you think about 3x plus 1, that is something that kind of looks like this. This is just a rough sketch. And if you were to do the item on the left here, your slope is 1/3 and your vertical intercept is negative 1/3 also. And so you would end up finishing something that looks like this. So this is what your f of x would be. This is your inverse of x, as some of you have seen before. And if you did your math right, okay, and you drew your graphing right, then one should be the reflection over the other with respect to the function y is equal to x, okay, or f of x is equal to x. All right, so one should mirror over the other and get the other, the inverse. Further, there was a rule that went like this, that if you took, let me change this color up, since that matches what I have here. Let's use green. Further, if you took f, and it's still not good, sorry. All right, this is great. If you took a composite function and you inputted the inverse into the x of the original function, you would find that, again, you're taking this and plugging into that x. When you work this out, okay, you should finish with just a plain x, okay? You can tell you did your work right if you, again, use as a composite function, plug one to the other, and you finish with an x, okay? Now, here's what we're gonna do. We're gonna take a derivative of an inverse function. And by this rule here, let me do this. Let's say for a second that f of x and g of x, I'm gonna call this basically a g of x here, and g of x are inverses. Okay, so what I'm going to do is instead of using f negative 1 of x, or the inverse of x, what I'm going to do is I'm going to plug my g of x in for this x. Okay, and what I know is that when I plug this into this guy and work it out just like I did over here to the right, I should finish with an x. Okay, now here's what I'm going to do. I'm going to take the derivative of both sides. Okay, now when I do that, I'm going to be careful with this left side because I'll take first the derivative of the f. I'm going to leave my g of x in the inside, and then by chain rule, I'm going to multiply by g prime of x. Okay, take the derivative of the inside, put it on right there. And then, of course, the derivative of x is 1. okay? And then finally, I'm going to solve for what this is asking for, the derivative of the inverse function. Now, the inverse function was this g of x, okay, or the f negative 1 of x. And so if I'm going to solve for the derivative, okay, I get 1 over, and then I get this big thing out front, f prime of g of x. Okay, and that is the formula that I'm going to use. It's like a mini proof of kind of the formula you're going to see on this next page. Okay, f prime of x is equal to 1 over f prime of g of x. Okay, and that's what you'll see right here. So here's what they're going to do. They're going to say, hey, this is a continuous function that's differentiable. Okay, you need to find the derivative of its inverse. All right, and some people are like, well, why don't I just switch the x and the y and solve for y? Well, take a look at that. If this is really what y is, and you switch that, okay, do you want to solve for y here? No, you can't. Okay, it's not possible. Okay, so or if it's possible, I can't think of a quick way to do it. Okay, so here's what you're going to do. You're going to use this little formula here, and they're asking for the derivative at 4. All right, so let me get a darker pen color here because you're not going to see the yellow and the white. And here's what I got. I've got g prime of 4. And I'm just going to plug in 4s into the formula as you see it, which again is the same one that you saw on the previous page. So that's f prime of g of 4. Okay, and again, g is the inverse of f. Now, here's what you have to think about. Okay, and it's kind of a little abstract to think about. Ooh, it's not right here. Let's say this. When I want g of 4, which is this guy, okay, I don't know what g of 4 is, but what that means is that f of something has to equal 4. Okay, so if I'm looking at this g of 4, what it means is, because it's an inverse, okay, that if I want to find this answer, what I really need to do is look at the f function, ask what do I plug into it so that at the end I get 4 as an answer. Okay, and they're kind of all done this way. So let me look at this over here. I'm going to take this f of x is equal to x cubed plus x plus 2. And all I'm going to say is that in the end, I need a value for x so that in the end it equals 4. Okay, and that feels kind of uncomfortable, okay, as you read this, but that's really what we're suggesting, okay? So here's what I'm going to do, and this will even sound more uncomfortable. You could graph this in your graphing calculator, this part on the right, and also graph 4 as well, and then figure out where they intersect, okay, and that will give you an answer. But these are designed in a way such that x should be really easy to figure out just using simple plug and chug, okay? And so if I think of, like, for example, the number 0, would it work if I plugged in 0 for x? Well, 0 plus 0 plus 2 is not 4. Okay, so that did not work. If I plug in 1, does it work? 1, yes, plus 1 plus 2 is 4. Yeah, so this works when x is 1. Okay, now some of you are like, are we always going to be that lucky? I will share that most of these are designed where if you just plug in maybe one of these numbers here, it's probably going to work. And in fact, if you had to go higher than 3, it would shock me. Okay, but they don't want you to spend a lot of time doing this. They want you to work on the derivative piece of it. And this is just a small component, but in this case, we found it pretty fast. Okay, and so let me reiterate what this means. When you plug in 1 here, you get the answer 4, and that's what you were seeking. Let me write that over here to the right. When you plug in 1, you get 4. Okay, if g is the inverse function, what that means is when you plug in 4 to the inverse, you should get an output of 1. All right, so these items are flips. Okay, if on the other screen you flip your x and your y to solve for the inverse, it's the same thing here. If this is my original and this represents your input of an x and your output of a y, then those are flipped around accordingly. Okay. All right, so that's really the trickiest part, okay, is taking your original function and set it equal to the number that they give you. and then trying to manipulate in your head what you think it could be. Some people do this. They'll just look down here, if you don't mind. They'll set this equal to 0 and subtract 4, and they'll get this. And while they may not be able to factor that easily, what they'll do is they'll put in their graphing calculator and just find the roots for it, or the 0, and it'll work. Okay. All right, so what do I got? I got 1 over f prime of, and we know that g of 4 is equal to 1. All right, and then you're pretty much done. F prime, I don't have that yet, but that's an easy derivative to find. That is 3x squared plus x, 3x squared, let me erase that. Not plus x, that is plus 1, the derivative of x is 1. Okay, and the derivative of 2, of course, would go away. All right, and if I want f prime of 1, okay, it ends up giving you, I think, 4. Okay, and in the end, you can leave it like this on an AP test. Okay, but I'll say this, it's usually not a free response question that they ask this for. It's typically a multiple choice. And of your 40, 45 problems that you get, I promise you, you'll probably see it once for sure. Okay, maybe twice, but they always show it once. And after you see it in this section, you're not going to use it a heck of a lot for the rest of the school year. Okay, so come in May when we're reviewing for an AP exam, you're like, oh, I've seen this problem before. When did we do it? And you're like, way back in the beginning of the school year in chapter 3, and this is the spot. Okay, so so know that you'll see it and it'll kind of go away, but you may have to rewind this video just to kind of capture everything that we talked about. It's not hard, but it's just a kind of elaborate process in order to get the result. And again, we have to do that because you can't find inverses of stuff like this. Okay, you can't switch your x and your y and solve for y. Sometimes students will think that's what they need to do, and they'll spend 30 minutes trying to solve for y that's not solvable. Okay, so do it this other method instead. Okay, they will sometimes do this, and let me write this I'll write it in white so you can see it. They'll sometimes do this. They'll say instead of using f prime of g of x, they'll use the other notation that we had, which is f negative 1 of x. And that just makes me feel like I have to think too hard. Okay, so whenever I see this, okay, I just replace it with my g of x and call that an inverse, and you can just do it that way. Okay, all right, here's the next piece, and this I think is either my last slide or my second to last slide. It's the derivative of inverse functions. Okay, inverse trig functions. All right, so do you have to have these memorized? I'll say in general you do. Okay, however, on an AP exam, there's 2 that are important. Okay, and I got to switch out of this white because you can't see it on the screen. Purple. All right, so you got to know the inverse sine, and you have to know the inverse tangents. Okay, the other ones exist. You'll see that they're actually very similar to the ones that they pair up with, like sine and cosine are exactly the same except for a negative sign. Same thing with tangent and cotangent. Okay, secant is kind of its own elaborate one and matches with cosecant. Someone in a previous class had noticed that all the ones that start with the letter C are the ones that are negative, and that student was right. Okay, all the ones that don't have a C in the beginning are positive versions of that. Okay, so here's what you're going to do. I'm going to take the derivative of f of x, which is f prime of x, and the derivative of an arc sine, which is the same as inverse sine, like this. Okay, so know that these mean the same thing. Sometimes people think they're completely different problems, but they're exactly the same. And I'm going to rewrite what I see in the numerator and in the denominator. So I've got 1 minus something squared, okay? And that something that's being squared is whatever this x is, okay? So that x is right here, it's really x minus 2. And then once you do that, you have to take the derivative of the item that you placed in for this x. And so the derivative of this x minus 2 is just a 1. You'll put that in the numerator, and that will kind of dissolve away because 1 times 1 is 1. And you do not have to simplify, okay? So don't multiply this out through what some of you call a FOILing method. Just leave it like this and know that you got it right and move on, okay? All right, next one. arctangents, okay? Arctangent of, gosh, this is the cube root of x. I'm going to call this x to the 1/3. I just think that looks a little nicer, okay? And that represents the second one. All right, so again, AP typically likes those two especially, okay? But if they said arctangent, I'm sorry, arccotangent, find the derivative of that, it's the same as the tangent, just put a minus sign out front, okay? Subtraction, negative sign. All right, so one goes on top, and then I've got 1 plus x squared. Now, x in this case, we said was x to the 1/3, okay? And most of you are like, yes, I'm done. However, don't forget you have to chain that piece out, all right? So you have to take the derivative of x to the 1/3. Now, if it's written like this, and you want to take the derivative, remember the 1/3 will come out front, and that's x to the 1/3 minus 1 is negative 2/3. Okay, so what does that mean? Well, let's see. Again, on an AP exam, you don't have to clean this up. You could really just stop right here and say, free response, I'm done. Okay, but if it's a multiple choice question, then it's probably going to be reduced a little bit to a cleaner form. X to the 1/3 to the second. Remember, power to a power means you got to multiply, and you can make that a 2/1 if you want. And multiplying fractions means you multiply the numerators together and the denominators. Gives you that. And the 1/3, okay, I'm going to put that 1 on top, and your third will go on the bottom. Okay, and then because this is a negative power, and that's traditionally not something that we enjoy seeing, we can make it positive, but we have to put it in your denominator. Okay, and I'm going to attach it to the back. Some people may put it between the 3 and the parentheses for this binomial. It's completely up to you, but this is my answer, and that is correct. Okay. All right, finally, last one is another item that has a arc sign with it. However, there is a 3x out in front, and sometimes they'll put a time sign there, sometimes they don't, but you'll have to understand that you're going to have to use a product rule here, okay? So it's a little bit more elaborate, takes another step. So product rule, first times the derivative of the second. So 3x times, now I'm gonna write some big parentheses here and use the sign item here. Inverse sign of 1 over the square root of 1 minus x squared. Now I'm gonna put 4x squared inside here and then square it just like that. Okay, that's kind of weird, but yeah, this is my x that I'm replacing with a 4x squared. Okay, further, once I input it, I have to take the derivative of it. So the derivative of 4x squared is 8x, and that will go in the numerator. Okay, all right, first times the root of the second plus second, which is the arc sign of 4x squared. Okay, times the root of the first. Derivative of 3x is 3. Okay, and is there anything else I want to do with this? Not really, okay? Really the only thing you could do is you could pull out a 3 and factor it out, but that's really not significant. You could mess with this 4x squared. If you did, okay, and I'm not going to do the whole thing, 8's on top. I mean, I'm not going to write the other, well, I'll just do it then, sorry. This is 1 minus, make sure you square the 4, okay? It's not uncommon on AP tests, they'll simplify it and they'll say, hey, this is x to the 4th. And one of the wrong answers will keep a 4 here, all right? And so what you want to make sure that is that you also square this and not make an algebra mistake. Okay, parentheses are important on these, and there's your 3. All right, that one fast. If you didn't get it, there you go again. All right, if you have any questions, holler at me. All right, be happy to help you out. And this is your assignments, okay? It's not too long. Be careful with your inverse items, okay? And we will talk to you soon.